This is the video for 6.2, and in lesson 2 we are talking about the substitution method. The substitution method is another way to solve a system of linear equations. And remember, when we say solve a system of linear equations, what we are saying is we are trying to find the xy coordinate that will make both equations true. In other words, their point of intersection. So the first way we solved a system of linear equations was through graphing. Another way that we can solve is through substitution. So the substitution method is solving linear systems by solving one of the equations for one of the variables, then substituting the expression for the variable into the other equation. So for example, if I say y equals 2x and 3x plus 4y equals 7, these are two separate equations for two different lines. But if I graph them both on the same coordinate plane, I will notice they will have a point of intersection. So how do I figure out what that point of intersection is? If y equals 2x, then I can take 2x and I can plug that in for y. And so that's what I did here. Then I can solve for x. And once you know the x, you can then solve for y. So that's substitution, and that's what we're going to be doing today. So let's look at example number 3. And remember, this is video number 2 of this lesson. I'm combining lessons 1 and 2 together, which is why I'm starting here at example number 3. Example number 1 and 2 was solving through graphing, and I did that on the other video. So y equals 3x, and x plus y equals negative 32. So I can solve by graphing, but I can also solve through substitution. If I know y equals 3x, then all I have to do is take that and plug that in for y into the other equation. So I know that y equals 3x, so I can say x plus 3x equals negative 32. Because remember, I said x plus y equals negative 32, and I know y is 3x. So now I know x equals negative 8. So I know that these lines are going to intersect at x equals negative 8. But what's the y coordinate that is going to make both of these equations true? Where are they going to intersect? At what y coordinate will these two lines intersect at? Well, all I have to do is I have to take x equals negative 8 and plug that back into either equation and solve for y. Remember, we're trying to find the xy coordinate that will make both of these equations true. So it does not matter which equation you solve it. It does not matter which equation you plug this back into. You should get the same answer. So I'm going to go ahead and take it. I'm going to take x equals negative 8, and I'm going to plug it in here for x, just because I think that one looks easier. And so then I get y equals negative 24. So the xy coordinate that's going to make both of these equations true, their point of intersection, is going to be at negative 8, negative 24. And if I wanted to check that answer just to make sure it's correct, all I have to do is plug it back into each one of these. When x is negative 8, is y negative 24? I do that for both of them and make sure that it works. So I could have solved this just as easily through graphing, but substitution is another way that we can solve a system of linear equations. So go ahead and hit pause and work out this on your own problem. And here's your answer. X is -8 and y equals -9. So the xy coordinate that will make both of these equations true is going to be -8, -9. Okay, example number 4. This is the exact same thing, except we don't have a variable that's already solved for. We need to take either equation and solve for either variable. It does not matter which equation, and it does not matter which variable. I need to take either equation and solve for either variable. But I'm going to go ahead and I'm going to take this bottom one and I'm going to solve for y because it looks easier. Because my coefficient, it's already 1y. So the math will just be a little easier with this one. Okay, so I know that y, or 1y, equals 2x minus 3. So now what do I do with that? If I know y equals 2x minus 3, I take that and I plug that into the other equation for y. Now, make sure that you plug it into the other equation. Don't plug it back into itself. So I know that y equals 2x minus 3. So then I can say 3 times 2x minus 3. And now I just solve for x. Again, it was 3 times y. And I know y equals 2x minus 3. So then I can say 3 times 2x minus 3. What's 14 plus 9? 23. Okay, so now x equals 23 over 10. So you can see already why solving using substitution is going to be much more efficient than solving by graphing. Solving by graphing only works if you have integers as solutions. If you get something like 23 over 10, determining that through graphing is going to be very, very difficult. So solving using substitution is much more accurate, much more efficient than solving by graphing, because what do you do if you don't have two integers as your coordinate point? If you don't have two integers, and if you have a fractional, if you have a coordinate point that's a fraction, that's very difficult to determine using graphing. So substitution is much more efficient. Okay, so now if I have x equals 23 over 10, what do I do with that? I take that and I plug that back into either equation for x. Does not matter which equation. So I'm just going to go ahead and I'm going to take the top one. So the top one says 3y plus 4x, but now I know x is 23 over 10. And so now I need to solve for y. I'm going to go ahead and cross reduce here just to make my math a little easier. Then I'm going to go ahead and get rid of my denominator, so I'm going to multiply everything by 5. So you can see where the math does get more complicated. 70 minus 46 is 24. And I can reduce that. 3 goes into that 8 times. There it is. So it looks somewhat like my y equals 8 over 5. So it looks like the answer is going to be 23 over 10, comma 8 over 5. Excuse me, 8 over 5. That's the coordinate point that's going to make both of these equations true. And again, how do I check my answer? You have to plug it back in. and figure out if it works. When x is 23 over 10, is y 8 over 5? And when you're plugging fractions back into the equations to check to make sure your answer is correct, it's usually easier to convert it to a decimal and then plug it back in as a decimal and then see if it works. Make sure your answer is correct. Okay, so here you go. Here's the next problem. Go ahead and hit pause and solve this using substitution. Here's the answer. X is 22 over 3 and y equals negative 43 over 9. And if you got that wrong, please redo it. Notice I said solve either one of the equations for either variable. So I solved the bottom for x. And then I got my y equals negative 43 over 9, and then I plug that in. Watch what I did to make the math easier for myself. I multiplied each term by 9. Once I multiplied each term by 9, this just ended up being 3 times negative 43 because that 9 canceled out. That was the whole point. The whole point of multiplying each term by 9 is to get rid of this denominator. So then the 9, the denominator here is gone, so then that's just 3 times negative 43. And that's what I did there. I kind of skipped a step. Maybe let me make sure you understand what I did here. I multiplied each term by 9 to get rid of my denominator. There you go. Once I multiplied each term by my denominator, that's what I was left with. And then 3 times negative 43 is negative 129. Again, if you got this wrong, please redo it because yes, the math is going to get more complicated. Okay, and finally, systems with infinitely many solutions or no solution. All right, so let me go ahead and solve using substitution. I'm going to plug that in for x. Okay, so remember I want to combine everything that's on the same side of the equality symbol first. So negative 7y and 7y cancel out, and what am I left with? I'm left with 14 equals 14. So whenever you are solving and your variable disappears, you are left with one of two situations. You either have a solution, you either have no solution or you have an infinite number of solutions. In other words, these are either the same line or they are parallel and they will never intersect. So here, since yes, 14 does equal 14, what am I left with, or what does that mean? That means these are the same line. And so there's an infinite number of solutions. Oh, I don't know how to spell infinite. Infinite number of solutions. So whenever your variable disappears, you either have an infinite number of solutions or no solutions. And if ever you're left with something that works out, like 14 equals 14, that means it's the same line. There's an infinite number of solutions. But now look at this next one. I'm going to plug this in for y and I'm going to solve. Okay, I have 3x minus 3x, so what am I left with? All right, that does not work out. And so what does that mean? No solution. These are parallel lines that will never intersect. So go ahead and work out this last one. And the answer is there's an infinite number of solutions. Now, you may have gotten something different here at the end than 24 equals 24 because you may have gone about solving this problem a different way. But it doesn't matter. At the end, you should have gotten something equals itself. And then that means there's an infinite number of solutions. There's 4 different ways to go about solving this. So there's 4 different possible answers you could have gotten at the end. But no matter what you did, no matter how you went about solving this, you should have ended up with a variable that disappeared, and you should have ended up with something equals itself. And so then there's an infinite number of solutions. These two equations are the same line. Okay, so go ahead and start your homework, and if you have any questions, let me know. And again, the concept here in algebra is not very difficult. The math itself is going to get a little bit more complicated. So be patient with yourself and rework the problems if you get them wrong, and I promise you it will get easier.